today in this virtual class we'll be looking at this question on number basis, how to change a decimal number from base 10 to binary. Okay, here we have 15.8125 in base 10 to binary. Remember that those number in binary, they are basically base 2s. So here we look at the number here, 15.8125 can be written as 15 plus 0.8125. It is very easy for the whole number part to be resolved, but let's look at the decimal part, which is 0.8125. Remember, if you are converting from other bases to base 10, especially if it involves decimal number, the first thing to do is to ensure that the base you add before converting to base 10, the first number after the decimal point is the index there should be -1. So that's how it go, -1, 2, and 3, and so on. Now here we used to approach here. The first one is to transform this decimal fraction or decimal number into a proper fraction. So, and 0.8125 is same thing as 13/16. So because we are changing to base 2, for having the denominator as 16 make our work easier. But the 13 at the numerator can also be expressed as 8 plus 4 plus 1, and all divided by 16. So we can also write this as 8/16 plus 4/16 plus 1/16. If you have the idea of basic operation of fractions, once this one is a simplified form, so we can also revert it to this form. Okay, so the 8/16 is same thing as 1/2. Then 4/16 is same as 1/4 plus 1/16. So what do we need to do here? We can also express 4 using a common base of 2 as well as 16. So this can also be written, can also be expressed as a negative indices. Here, as this is 1 times 2 raised to minus 1. Now, for instance, 2 square is 4, so 4 can also be written as 1 times 2 raised to minus 2. Then 1/16, 16 can also be expressed as 2 raised to 4. So here, or putting it in a negative indices could become 1 times 2 raised to minus 4. Now remember, in changing base from other base to base 10, once you are expressing all the numbers after the decimal point, they move from -1, -2, -3, and 4. But since -3 is missing in this aspect, all we need to do for us to understand that is being multiplied by 0. That is why it is missing. So here you can say this is 1 times 2 raised to minus 1 plus 1 times 2 raised to minus 2 plus 6 -3 is missing, so that means this is 0 times 2 raised to minus 3 plus 1 times 2 raised to minus 4. So it means that for the decimal part, remember that in base 2, the face values, that is the face value there are 0 and 1. So digits value that will appear in base 2 are 0 and 1. So here is going to be 1, 1, 0, 1. So this part here is simply what? 1, 1, 0, 1 in base 2. That's the decimal part. Now let's find for the whole number part, which is 15, and that is easy for us to handle. So here we continue to divide using what we call division by the base, and each time we keep a remainder. So here 2 in 15 is 7, leaving a remainder of 1. 2 in 7 is 3, leaving a remainder of 1. 2 in 3 is 1, leaving a remainder of 1. So 2 in 1 is not possible, so we bring this 1 down here. So we read upward, and this become the whole of 15.8125, the same as 1111.1101 in our base 2. Now this is how to handle this. Now in my next video, I will be looking at another approach for handling it without necessarily converting this to a proper fraction. So see you in my next virtual class. Please, if you like this video, help me subscribe, follow my Facebook page for more important videos.